So this is the second video. Obviously, it's been a couple of years or something. I decided that I would, instead of starting this whole series, I'm actually writing a book on electricity that I'm most of the way through with. But I'm trying to help somebody else pass their NERC exam, and having a conversation with that person, I realized that they had a little bit kind of a struggle of understanding the nature of series and parallel and how you would add circuits, elements together, for example, resistance, capacitance, inductance, and the differences between a series and parallel circuit and what that might mean for adding capacitance in. I guess the specific question had something to do with adding capacitance in series means that you will lower the overall capacitance of that circuit, and why that would make sense. So that's series, parallel, and add in capacitance. Going through all that, I guess where to begin. I already recorded this once, and then I didn't record the audio because I'm super awesome and I don't really like the lighting that I've got. Maybe it's overly dramatic for a training video, but it's what I have for right now. A series circuit, everything is in a line. So imagine a square. A square's got a top, bottom, left and a right side. On the left side, typically that's where you're going to draw your power source or your battery. On the top, say you got a resistor 1, right side, resistor 2, bottom side, resistor 3. That's a series circuit coming in a loop from the top of that battery to the bottom of the battery, making a complete circuit. In series, if you're going to add resistance, you would add R1 plus R2 plus R3, and that's going to give you your total resistance, or R total. The numbers for the resistance could be 1 ohm, 2 ohms, 3 ohms. Ohm is the unit for resistance. You'd have 3 plus 2 plus 1, which is going to be 6 ohms for the total resistance in a series circuit. A parallel circuit is going to be one in which there is a node. And a node means that something is coming into a branch or a juncture. It's going to split off like a Y. And some current is going to take the top path, some current is going to take the bottom half. So if you kind of imagine two squares next to each other, well, at some point you're coming along, that you come up to the top of out of the top of that battery, you go over to the right, and then you're going to hit a juncture right there. You're going to hit a node. Some of that current is going to keep going straight, and some of it's going to come down to travel. So there's going to be current coming through that second square that's attached to the first square. So we'll talk about Kirchhoff's current law. The easy way to say it is the ins equal the outs. So whatever comes into that node, that's what's coming out of that node, unless you have some sort of a problem. You could have disaster strikes. A car hits that one area, and now that piece of material doesn't exist anymore. But outside of that, whatever comes in, that's going to be the stuff that's leaving, and in some combination. Depends on the resistance. The electricity is going to take every path available to it, but it's also going to prefer to take the path of least resistance. So if the two resistors have different values, you're going to have more current on one path, less current on the other path. Imagine now that you have 3 circuits where you have, or one circuit, but you have 3 resistors in parallel on this circuit. Now, when you're going to add these together, what you get is 1 over R1 plus 1 over R2 plus 1 over R3. But 1 over R1, so it's 1 over. So let's just take the bottom portion of that and think about 1 over R1 plus 1 over R2 plus 1 over R3. So we'll use the same values. We'll have resistor 1 is 1 ohm, resistor 2 is 2 ohm, resistor 3 is 3 ohms. So we're going to have 1 over 1 plus 1 over 2 plus 1 over 3. Well, 1 over 1, that's 1. Plus 1 over 2, that's 1/2, 0.5. And 1 over 3 is going to be a third, or 0.333333, right? So we're going to have 1 plus 0.5 plus 0.333333. So we're going to have 1 plus 0.5 is 1.5 plus 0.333. You're going to have 1.8333333. Now that we have 1.833, just because I'm not going to keep doing that, 1 over 1.8333. Already we can tell that this number is actually, it's going to be kind of close to 1/2, right? But we already know that this is going to be smaller. So the actual answer is like 0.545, I believe. That's the total ohms. 0.545, wow, that's less than 1, and it's less than 2, and it's less than 3. So when we added those resistors in parallel, instead of getting some value that's greater, like we had 3, 2 plus 1, now we have 6 resistance if it was in series. In parallel, we have 0.5. Adding resistors in parallel reduces the overall resistance of that circuit. Inductance and capacitance, they have the same formulas, but they're used differently. Well, one of them is used differently. So inductance, an inductor, if you're going to add, and the unit on that is henries, but if you're going to add inductors, what you're going to get is the exact same equations as you're going to get with resistance. Inductors in series, inductor 1 plus inductor 2 plus inductor 3 is the total inductance. The parallel is going to be 1 over inductor 1 plus 1 over inductor 2 plus 1 over. So you're going to have adding inductors in series is going to reduce the inductance of that circuit. Capacitance is the opposite. Adding capacitors in series is 1 over capacitor 1 plus 1 over capacitor 2 plus 1 over capacitor 3, while adding capacitance in parallel is capacitor 1 plus capacitor 2 plus capacitor 3. So adding capacitors in parallel increases circuit capacitance. Adding capacitors in series reduces capacitance. I do want to add, I think I forgot one thing. As you're kind of mashing everything together, I'll just have a picture. And on this picture, it's going to be this crazy looking circuit. You're going to need to combine the parallel element to make it a series component. If you have two resistors that are in parallel, in order to get the total resistance of the circuit, you need to make those parallel resistors pretend that they're one. Well, how do we do that? We're going to add them in parallel. So you'd have 1 over resistor 1 plus 1 over resistor, the parallel resistor. You'd get a value for that, and you would label that the resistance equivalent, what do we do? It's been so long since I've done this. REQ, I think. So then you would have, instead of saying resistor 1 plus resistor 2 plus resistor 3, you'd have resistor 1 plus resistance equivalence plus resistor 3. This isn't supposed to be about adding resistance or really Kirchhoff's current law. It was just a good, the ins equals the outs. That's important. This is what a node is. That node is going to make the difference between a series and a parallel circuit. And overall, this is how you would add them in general. There's not really going to be any math. There's no math on the NERC exam. There is on the ERCOT exam. They had some stuff like that when I took it. It's just kind of a general idea of how these elements of electricity work together.